So hey guys, a very good day to you all. In this video, first we will understand what is an oxidation number and why there was a need of the concept oxidation number. And then we will understand how to find the oxidation number of an atom in the molecule or an ion. So let's start with the first topic, that is what is the meaning of an oxidation number. So, as we all know, oxidation is loss of electrons and reduction is gain of electrons. This is the basic knowledge that we all know. Now, keeping this thing in mind, let us understand the formation of an ionic compound, and let us consider the sodium chloride, which is an ionic compound. So, what happens during the formation of sodium chloride is that we have a atom of sodium and we have a atom of chlorine. Now, the sodium atom has one electron in the outermost energy level, whereas the chlorine atom has 7 electrons present in the outermost energy level. Now, since the chlorine atom has 7 electrons present inside the outermost energy level and it requires one more electron to complete its octet, whereas this sodium atom does not require this one electron which is present in the outermost energy level. So what is going to happen over here is that this one electron of sodium atom is going to get transferred to the chlorine atom. As you can see over here, that the electron has now transferred from the sodium atom to the chlorine atom. Now, due to this, what happens is that, can I say that the number of electrons in the sodium atom has now decreased, and since the number of electrons has decreased, therefore the sodium atom gains a positive charge, and since the number of electrons in the chlorine atom has now increased, therefore the chlorine atom gains the negative charge. And as we all know that opposite charges attract each other, therefore the positively charged sodium atom is going to get attracted towards the negatively charged chlorine atom, and due to this there is a ionic compound formed between sodium and chlorine, which is called as sodium chloride. Now, one thing you need to observe over here, can I say guys that this sodium atom is undergoing oxidation? Why oxidation? Because oxidation is nothing but loss of electrons, and this sodium atom is losing a electron. Therefore, we can say that the sodium has undergone oxidation. Similarly, can I say that chlorine has undergone reduction? Why? Because reduction is nothing but gain of electrons, and here the chlorine atom has gained a electron. Therefore, the chlorine atom has undergone reduction. So during the formation of an ionic compound, it is easier for us to distinguish between which atom is undergoing oxidation and which atom is undergoing reduction. But what happens during the formation of a molecule compounds is that, let's understand. So for that, I have a hydrogen atom and I have a chlorine atom. And as we all know that in the last energy level of chlorine there are 7 electrons present, whereas hydrogen has only 1 electron. Now, this chlorine requires 1 electron to complete its octet. It requires 1 more electron to complete its octet. Whereas this hydrogen requires 1 more electron to attain a stability. So both of them require one more electron each. So what they are going to do is that hydrogen will contribute its one electron and chlorine will also contribute its one electron. And with the contribution of one electron each, they will share these two electrons. As you can see over here, now the hydrogen has 2 electrons, whereas the chlorine has 8 electrons present in its outermost shell. So here there is no transfer of electron taking place. Instead, both the atoms are sharing the electrons, and the bond formed by the sharing of the electrons is known as the covalent bond. So here you cannot distinguish which one is going an oxidation and which one is going an reduction. So for that there was a concept introduced called as the oxidation number. Oxidation number. So what is the meaning of oxidation number? Oxidation number, or the oxidation state of an atom which is present inside a molecule or a ion, is defined as the number of charges it would carry if electrons were completely transferred. Let's read it once again. So, oxidation number, or the oxidation state of an atom which is present in a molecule or as an ion, is defined as the number of charges it would carry if electrons were completely transferred. What is the meaning of this? Let's consider our previous example itself. So here what we are going to do is that, as we all know, when you compare hydrogen and chlorine, chlorine is more electronegative than hydrogen. Now if I want to know why chlorine is more electronegative than hydrogen, then guys, I have already made a video in the on trends in electronegativity. You can find the link in the description box below, or you can simply click on this link over here. Okay, now since chlorine is more electronegative than hydrogen, therefore this pair of electrons is going to get shifted towards the chlorine atom. Now here we make a assumption, a total assumption over here, that these two electrons will get transferred to the chlorine atom. So if both these electrons get transferred to the chlorine atom, so guys, can we say that hydrogen will gain plus one charge? Why hydrogen will gain plus one charge? Because hydrogen is going to lose its one electron, and if it loses its one electron, therefore it is going to gain plus one charge. Whereas the chlorine will gain minus one charge. Why chlorine is going to gain minus one charge? Because chlorine is gaining one more electron. In actual, the electrons will be shared, but we are making one assumption that since chlorine is more electronegative, therefore this pair of electrons will get transferred to the chlorine. That's what our definition says. Electrons were completely transferred. Okay, so according to our definition, we assume that these electrons get completely transferred, so it is obvious that chlorine will gain one extra electron, therefore it will gain minus one charge, whereas the hydrogen is going to lose its one electron, therefore it is going to gain a plus one charge. Okay, so hydrogen will gain plus one and chlorine will gain minus one charge. Now this plus one and this minus one are nothing but the oxidation numbers. So the oxidation number of hydrogen in HCl molecule, hydrogen in HCl molecule will be plus 1, whereas the oxidation number of chlorine in HCl molecule will be minus 1. So I hope you have understood what is the meaning of an oxidation number with the help of this example. Now this was a pretty easier example, but how to find the oxidation number of an atom in a molecule which is more complicated? So to understand that, there are 8 rules that you need to understand. So let's start the 8 rules one by one. The rule number 1: the algebraic sum of the oxidation states of all atoms in a neutral molecule is 0. What is the meaning of this? Let's understand with the help of an example. So here we take the example of a molecule of HCl, the same example, to understand in a better way. Okay, so the oxidation number of hydrogen, HCl is made up of hydrogen and chlorine atom. So the oxidation number of hydrogen plus the oxidation number of chlorine should be equals to 0. Okay, should be equals to 0. Now what was the oxidation number of hydrogen? It was nothing but plus 1, whereas the oxidation number of chlorine was nothing but minus 1. So plus 1 and minus 1 automatically gives you 0. So the sum of the oxidation states, or the oxidation number of the atoms present in the molecule, must be equals to 0. So I hope you guys have understood the rule number 1. It was a quite simpler one. Now let's move on to the rule number 2. The algebraic sum of the oxidation number of all atoms in a polyatomic ion is equal to net charge on it. What is the meaning of this? Let's again take an example of SO4 2 minus. Now, what is this 2 minus, guys? This 2 minus is nothing but the charge on SO4. The charge on SO4 is nothing but 2 minus. Therefore, the oxidation number of S sulfur plus 4 times oxidation number of oxygen. Why I am taking 4 times oxidation number of oxygen? Because here there are 4 atoms of oxygen present. Therefore, oxidation number of sulfur plus oxidation number of oxygen is going to be equal to -2. Why -2? Because the total charge on the polyatomic ion is -2. Whereas in our previous example, in HCl there was no charge. Can you see any charge over here? No. Therefore we have to take 0. So I hope you have understood the rule 2 as well. Now moving on with the rule 3. The oxidation state of an atom in the free elementary state or any of its allotropic form is always 0. Now, what is the meaning of this? Again we will understand with the help of an example. For example, the oxidation number of helium. Now here helium is present as a single atom. So whether it be helium or any other atom, any other element, if it is present as a single atom, the oxidation number will always be 0. So I repeat myself again. The oxidation number of helium is 0. This is not the case only for helium. Whether it be any atom of any element, the oxidation number will always be 0 for a single atom. Next, oxidation number of hydrogen in H2. The oxidation number of hydrogen in H2 will again be 0 because this is the free state of hydrogen. Hydrogen is found as H2 in nature. Can you see over here hydrogen combining with any other element? No. Therefore, the oxidation number of hydrogen will always be 0. Okay. So whether it be hydrogen or any other element which is found in a free state as a molecule, we always have the oxidation number as 0. Next, the oxidation number of sulfur in S8. S8 is an allotropic form of sulfur. Here also the oxidation number of sulfur will be 0. Now another example is carbon in diamond. Carbon has different allotropic forms. Carbon has graphite, diamond and various forms. So in that also the oxidation number of carbon will be 0. Next, moving on with the fourth rule. The oxidation number of atom varies with change in molecule. This is the most important point, guys. See, let's understand with the help of our example over here. Okay, so here what was the oxidation number of hydrogen atom? It was +1, right? And the oxidation number of chlorine atom was -1. So it is not compulsory that the oxidation number of hydrogen atom will always be +1. It is +1 for HCl molecule. It may vary as the molecule changes. I repeat myself again. The oxidation number of hydrogen is +1 only for molecule of HCl. It may vary or may not vary as the molecule changes. So if you consider some another molecule, it is a possibility that the oxidation number of hydrogen may be different. Now how it can be different, we will understand that. Don't worry about that. Okay. Now, so I hope you have understood the fourth rule, I guess. Yes. So you have understood the fourth rule also. Moving on to the fifth rule. The oxidation number of an atom in a monoatomic ion is equal to its charge. Now what is the meaning of this? Suppose you have chromium 3 plus. Okay, you have an ion of chromium over here. So what will be the oxidation number of chromium? Here the oxidation number of chromium will be plus 3. If any ion is present, the charge will be its oxidation number. So here the charge on chromium is plus 3. Therefore, the oxidation number of a chromium atom is plus 3. Similarly, guys, you will comment the oxidation number for S2 minus, that is the charge on sulfur is 2 minus. So what will be its oxidation number? You will have to comment below in the comment section. Now, moving on with the rule number 6. The oxidation number of hydrogen is either plus 1 or minus 1. See, as we all know that hydrogen has only one electron. So the oxidation number of hydrogen is either going to be plus 1 or either it is going to be minus 1. Now when it is going to be plus 1, let's understand that. When hydrogen atom is bounded to non-metal, its oxidation number is plus 1. This ON is nothing but oxidation number. So when an hydrogen atom is bonded to non-metal, its oxidation number is plus 1. Why plus 1? Because non-metal are more electronegative than hydrogen. Therefore, oxidation number of hydrogen will be plus 1. Whereas in the case, for example, H2O, okay, so here oxygen is a non-metal. So when the hydrogen atoms, two hydrogen atoms are attached to oxygen, the oxidation number will be plus 1. Whereas when hydrogen atom is bonded to metal, its oxidation number is minus 1. For example, lithium hydride. Here the hydrogen is bonded to lithium, which is nothing but a metal. So in this case, the oxidation number of hydrogen will be minus 1. So I hope this was another simple rule, rule number 6. Then moving on to the rule number 7. The oxidation number of oxygen is usually minus 2 in most of the compounds. I repeat myself again. The oxidation number of oxygen is usually minus 2 in most of the compounds. But there are certain exceptions. Except for peroxides or peroxide ions where the oxidation number is minus 1. Now what are peroxides? Peroxides are nothing but a molecule inside which two hydrogen atoms are bonded to each other. I repeat myself again. A peroxide is a molecule inside which two hydrogen atoms are bonded to each other. So oxidation number of oxygen is usually minus 2 except for peroxide or peroxide ions where the oxidation number will change to minus 1. The example of a peroxide is H2O2. So this inside this molecule H2O2, both of these oxygen atoms are bonded to each other. Now moving on to the rule number 8. The rule number 8 states that the oxidation number of fluorine atom is always minus 1. Why? Because fluorine is most electronegative element known up till now. So the oxidation number of fluorine is always going to be minus 1, whether it be any compound or any molecule of fluorine. Fluorine will always have oxidation number as minus 1. Next, but other halogens like chlorine, bromine, iodine usually have oxidation number as minus 1. Usually their oxidation number is also minus 1, except for the compounds in which chlorine, bromine and iodine are bonded to oxygen. So let me explain here. The oxidation number of fluorine is always going to be -1, no doubt about that. But for chlorine, bromine and iodine, they will usually have oxidation number as -1, except for the compounds in which they are bonded to oxygen. There the oxidation number will turn to +1. So usually chlorine, bromine and iodine will have -1, but in a molecule where they are bonded to oxygen, their oxidation number will turn to +1. So again, this was a quite easier one. Now I hope guys you have understood all the 8 rules. Now if you have understood all the 8 rules, let us find the oxidation number of atoms in some of the examples, which will help you all clear this topic. Okay, so for that let's move on to my book. So guys, basically we will see 3 examples which will help us to clear this concept. Okay, the first example, let us consider S2O3 2 minus molecule. Now inside this molecule there is a sulfur atom and there is an oxygen atom. We know the oxidation number of an oxygen atom is nothing but -2. Why it is -2? Because the oxygen is not in a peroxide molecule, therefore it will be obviously -2. We have seen in the rules, but we do not know the oxidation number of a sulfur atom, therefore we assume it to be X. Now the total charge on the molecule is -2. Am I right? So let us write the algebraic sum of them. So 2 times S. Why 2 times S? Because there are 2 atoms of sulfur present over here. So 2 times X. So what is X? X is nothing but the oxidation number of one sulfur atom. But since there are 2 sulfur atoms, therefore I am writing 2 times X. Plus, how many oxygen atoms are there? There are 3 oxygen atoms. So 3 times oxidation number of one oxygen atom, which is nothing but -2, which will be equals to the total charge, that is nothing but -2 again. Okay, so now after solving this equation we get 2x minus 6 is equals to -2. Therefore 2x will be something, this -6 goes over there, becomes +6, so it will be 4, and the value of x that you will get is nothing but +2. So the oxidation number of sulfur will be +2. So now you know this value, which is nothing but +2. So it was easy, right? Let's take another example. Let's take an example of HNO3. Here there are 3 different elements present: hydrogen, nitrogen and oxygen. You know the oxidation number of hydrogen. What is oxidation number of hydrogen in this case? It is +1. Why? Because hydrogen is bonded to a non-metal. You know the oxidation number of oxygen as the same as this, -2. Why -2? Because oxygen is not in a peroxide form over here. But you do not know the oxidation number for nitrogen atom, so you assume it to be X again. Now how many hydrogen atoms are there? 1. So 1 times oxidation number of hydrogen, which is +1, plus how many nitrogen atoms are there? 1. So 1 times oxidation number of nitrogen, X, plus how many oxygen atoms are there? 3. So 3 times oxidation number of oxygen, that is nothing but -2, which will give me total charge on this molecule is 0. Can you see any sign or any charge on this total molecule? No. If there is no charge present, therefore you have to take it as 0. I think this was the second rule that we did. Now 1 into 1 will obviously be 1 plus x plus minus 6 will be equals to 0. So we shift this 1 and 6 to that side. So becomes X is equals to 5. So here can I say that the oxidation number of nitrogen atom is plus 5. So again this was a quite easier one. Now the third example, CrOH 4 times minus sign. This minus sign is on the total molecule. Now again, do we know the oxidation number of chromium? No. So we assume it to be X. Then do we know the oxidation number of oxygen over here? It is obviously minus 2. Why minus 2? Because it is usually the oxidation number of oxygen is usually minus 2 and it is not a peroxide molecule, therefore it will be obviously minus 2. Then for hydrogen it is obviously plus 1 because hydrogen is bonded to a non-metal. Now here you need to be careful. See, how many chromium atoms are there? 1. So 1 times oxidation number of chromium, that is nothing but X. Then plus how many oxygen atoms are there? Here there is a twist. How many oxygen atoms are there? There is no one oxygen atom, but instead there are 4 oxygen atoms present. Can you see over here? This 4 is for complete bracket. 4 times oxygen and 4 times H, which gives us 4 times OH. So there are 4 oxygen atoms present. So 4 times oxidation number of oxygen minus 2 plus again 4 times H, which will give you, what is the oxidation number of H? Plus 1, and the total charge is minus 1 on the molecule. So again you solve this, X minus 8 plus 4 minus 1, minus 8 plus 4, X minus 4 is minus 4. You shift this on over here, you get X is equals to plus 3. So can I say guys, X is nothing but the oxidation number of chromium. Okay, so guys, this was few examples how you can find out the oxidation number of an unknown atom. Now I would like to tell you one thing, that whichever 3 examples that we have solved over here, we have solved only on the basis of knowing the values of oxygen and hydrogen. We also know the values of fluorine, chlorine, bromine, iodine, but it will be better if you all know the general values of oxidation number of some other elements as well, because it will help you all to solve many such molecules during the competitive examination. So it is upon you how many oxidation number values of how many elements you learn. It will help you all that much in the competitive examinations. So guys, do check out my channel where I have uploaded physics and chemistry videos. They might be helpful for you all. And guys, don't forget to subscribe to the channel for more such interesting videos. Thank you for watching this video.